All right, welcome everybody. It is the top of the hour, so we will get started. Welcome to our NAGT webinar. The NAGT webinar series is your one-stop shop for strengthening work in Earth education. Webinars in our series feature novel and innovative work in Earth education, research, and pedagogy, new teaching materials, and the classroom and professional experiences of people just like you. Our series is free and open to the public, and we encourage you to invite your colleagues to attend and join our discussion. Just a quick reminder that all meetings and events are expected to abide by the NAGT Code of Conduct, which applies in all venues, events, and online forums associated with NAGT. I just pasted the NAGT Code of Conduct policy in the chat, so please check that out if you haven't already or have any questions about what that Code of Conduct entails. With that, I'm going to pass it over to Catherine to introduce today's speakers.
Thanks so much, Bradley. Great to see everyone here today. Thank you so much for joining us. My name is Catherine Rehimaki. I'm formerly of Princeton University, now working for an environmental company called Second Nature. And I am very pleased to be the organizer for today's webinar. This is actually the third of 4 webinars in a series sponsored by an NSF grant that is supporting the NAGT workshop for early career geoscience faculty. For those of you who are unaware of the program, this is an amazing week-long workshop each summer that supports geoscience faculty in their first 3 years of a faculty position. The deadline for 2022 has passed, but if you are an early career faculty member or have colleagues who are, please keep an eye out for the 2023 application. And I'm about to put the link to the workshop page into the chat for everyone. Our previous 2 webinars in this series were on February 15th from Erica Marin Spiota, discussing the Advanced Geo program and their survey on the climate of the geosciences, and on April 7th from Hendrada Ali, speaking about how to create inclusive research and scholarly groups. Our final webinar in this series will be next week, May 26th, with a panel on how diversity, equity, and inclusion efforts should be valued in promotion and tenure, with Tessa Hill as moderator and panelists Joshua Villalobos, Aaron Velasco, Aradhana Tripathi, and Christina Ravello. You can find information about all 3 of those webinars and this one, of course, including registration for next week's webinar on the NAGT website. And that link is also in the chat. Finally, I want to put in a shameless quick plug for the NAGT program that I oversee, the Traveling Workshop Program. We facilitate strategic planning workshops for Earth and environmental programs across the country, with 2 of our trained facilitators developing and implementing 1 to 2 day workshops in collaboration with the host faculty. If you are interested in transforming your program around DEI, curriculum, or any other topic, please look at our website or contact me directly. And you will sense a theme here. That information is in the chat. I am now pleased to introduce today's speakers, Lisa White and Phoebe Cohen. They are both exceptional educators and paleontologists. Lisa is Director of Education and Outreach at the University of California Museum of Paleontology, which she joined in 2012 after a long tenure as faculty and administrator at San Francisco State University. She's also the chair of the Diversity and Inclusion Advisory Committee at AGU. Phoebe is chair and associate professor of geosciences at Williams College. Go Eeps. She was one of the founding leaders of the Unlearning Racism in the Geosciences program, the URGE program, which in 2020 started a concerted effort to identify and address structural racism in our discipline. Before I turn it over to them, one last thing is that you should feel free throughout the webinar to use the chat for any questions, in particular during the first part. We'll then have breakout rooms followed by a more formal Q&A session. So I expect that there will be ample opportunities for discussion. All right, with that, I turn it over to Phoebe and Lisa.
Thank you so much, and thanks to everyone for joining us. So Lisa and I are going to share some slides. So I'm going to go do that now. Okay. So here's just a quick outline of what we're going to do. We're going to talk a little bit about some of our sort of favorite research papers. Obviously, there's a huge body of research by so many amazing scholars. So we're just going to be highlighting a couple that I think of as sort of framework papers, and then some that get into more specific research questions. Then Lisa's going to talk about her understanding science framework. I'm going to talk about some applications in the classroom. And then we're going to give you an opportunity to just dive right in and start working on thinking about how to incorporate these ideas and these processes into your teaching and education modules. Okay, Lisa, you're up.
All right. Hi, everyone. Really glad to be here with you. So this academic year, I've been running a professional learning community with two-year college instructors, and we've been trying to reshape some learning materials we've been developing around model-based inquiry and really using phenomenon to lead when we're teaching and learning. So I've been drawn to the Ambitious Science Teaching book and really been thinking a lot about the importance of really the attention to equity as you're building more robust and expanded teaching materials that really draw from a strong sense of intellectual engagement. So just wanted to mention via this slide that the role of equity should be central to everything that we do in teaching science, and especially in geoscience. There's so many opportunities to really situate learning in places and contexts that we want students to better relate to. And we also want to create opportunities where we can be very responsive to the way students are learning and connecting with information and ideas. And so as we share with you today in this webinar, some of the tools that we use, I'll be excited to highlight some materials we have at the Museum of Paleontology for allowing students to share their knowledge along the way as they're learning things and really be responsive and supportive of the notion that scientists do need to be more explicit in how they share and defend and generate claims, and knowing and supporting students in being able to do that. And through these kinds of exercises and tools and materials that we have, I think there are real opportunities to revisit some of the norms that we put in place for our classes and encourage more opportunities for the kind of sense-making dialogue and ongoing assessments that can really form and shape opportunities for students to show us what they know. Okay.
So the next framework I'm going to share is by Brian Doonesbury and colleagues, and the URL to this is at the bottom. And this comes from a life science group, but I think for like so many things, these frameworks are applicable in the geosciences as well. And so this is an interactive sort of pathway where you can click on any of these buttons here, and they'll send you into information. But I think some of the things that I think are really critical about this is that a lot of it hinges, if you go through here, you're not actually getting to what's happening in the classroom until over here, right? But a lot of this work is work that's happening before you even walk into the room. And a lot of it is about, as a faculty member, developing self-awareness, empathy, thinking about classroom climate, and then making pedagogical choices. And I think that's a really critical part of this framework and the way that I think about my teaching. It's not just about the mechanics of what I'm doing in the room, although that matters as well. How am I entering the classroom? What's my philosophy? What am I trying to achieve with my students? And how do I view them? So if we do sort of dive into this a little bit more, this website does a really great job of providing literature to back up a lot of these things that we might have sort of become familiar with as instructors who have been hearing this word like active learning or inclusive teaching. And so fostering a sense of belonging is a really critical part of this work, and something that I think a lot about in my work as a teacher. And that can be, language in your syllabus, language that you use in examples in your classroom, specific assignments and how you write them, using diverse examples and diverse scientists in the literature that you might use in your classroom. And there's a lot of really interesting research on sort of direct interventions for specific groups of students that have shown to really create increased confidence and increased sense of belonging, which is extremely important for student retention in the geosciences, especially minoritized students of many different identities. And then here is just a few of my favorite take homes from thinking about more specific classroom mechanics. So things like increasing course structure through having not all assignments be in class. So, moving sort of assessment outside of a sort of time pressure space, in-class active learning, cooperation and reducing competition, emphasizing relevance, supporting students' sense of autonomy, and fostering the ability of students to see themselves in research. And I'm going to give some examples about how I try to bring those things into my classroom a little bit later. But I think these are all critical points that can be brought into all different kinds of educational environments. And then we're just going to talk a little bit about some of our sort of favorites. So this one by Kimberly Tanner, who's a former colleague of Lisa's at San Francisco State, still a colleague, but former at the same institution. I come back to this one all the time because it's like, when you're getting ready to teach a class, you could literally open this paper and there's like, okay, here's 21 inclusive strategies. And I've just highlighted the ones below that I sort of use the most or that I come back to the most. And some of them are so simple, like literally just waiting when you ask a question. And there are some really cool studies that show that waiting 1 to 2 seconds, which is what we normally do, versus 4 to 5 seconds actually makes a really big difference in terms of who responds, who might raise their hand, who might volunteer an answer. Providing time for writing and reflection in class, doing active learning activities like think, pair, share, where students think about something by themselves for a minute or two, they discuss it with a neighbor or a small group of students, and then share out to the whole class. Doing less, which could be a life philosophy, but focusing more on student learning and the student experience as opposed to content delivery. Assigning reporters and small group work so that different students are placed in different roles that might be outside of their comfort zone, but doing it in a way that is constructive and supportive. Learning student names and pronunciations, centering group work, relevant diverse examples, not judging responses even if they're incorrect, and focusing on classroom community. So, you're probably hearing a lot of the same things coming up over and over again here, and that's because there's a lot of really wonderful research that shows that all of these things actually do make a difference in the classroom for student learning, student sense of belonging. A few geoscience specific ones that I just wanted to highlight. These are just some new ones that I have found pretty compelling. So this is one by Sarah Sheffield and colleagues, where they basically introduced students to individuals with marginalized identities who were scientists or who had a major influence on science. And they did interviews with students afterwards. And what they found was that participants with marginalized and non-marginalized identities broadened their preconceptions of who belongs in science after this intervention. And so I just pulled a couple of quotes from the structured interviews up here. The first one, I know we talked about a queer scientist, I'm queer, so that's the connection. One student reported that it made them actually switch their major. And so, we might not think of this as being a huge intervention, but research is showing us that students are actually paying attention, they're actually noticing, and this is actually influencing potentially the choices that they make. A few other ones that I'm just highlighting from one of the most recent issues of the Journal of Geoscience Education. And if you don't have a subscription to this, if you're an NAGT member, you do, definitely recommend it because there's always a really amazing stuff coming out of the geoscience education research community. And here again, I'm just highlighting a couple. The first one is an intervention about math anxiety, which some of us might face in courses in the geosciences that are more quantitative. And here the author basically rewrote questions to be geoscience specific and found that reduced anxiety. And then the second one was looking at the fact that active learning is a really big term, right? And so active learning for many people, especially in large lectures, can just mean using clickers. And so what these authors did is they compared that sort of just clicker-based active learning approach to clickers and having students predict, observe, and explain. So make a prediction about something, make an observation, and then explain. And that's a really powerful framework. It's been used a lot in the physics teaching community to help students sort of identify their own preconceptions or ways of knowing, and then reconstruct those based on observations. And so this work found that the predict, observe, explain model led to more engagement with the content material. And it didn't lead to more learning gains compared to the clickers, but what was really cool is it basically led to students being more interested in the geosciences and having more self-efficacy, which I think is really cool. And so we hear this term active learning all the time, but it's, not all active learning is created equal. And so I think one of the take homes from this is just like our rush through some of our favorite papers, but there's a very deep literature here, and really encourage all of you to, if you're not already engaging with it, to do so.
Great. So I'll jump in here. And Phoebe mentioned the importance of students connecting to science, their perceptions of science, and how they relate to many of the topics that we share in our courses. And several years ago, as an add-on to one of our Museum of Paleontology websites, Understanding Science, we created an interactive tool to better connect users to what we call the Understanding Science flowchart, or the How Science Works flowchart, that we'll have a chance to explore during our webinar today. And our main goal in sharing this tool more broadly is to provide users with an opportunity to really visualize and explore the nature and process of science. So we know from experience that science is nonlinear, but often the way it's taught or the way students are first introduced to science, even pre-college, can be a complete turnoff. It seems one-dimensional. They're unlikely to see people like themselves doing science. And if they haven't had research experience yet, they just may wonder, what is it that drives scientists in their work? Who decides, who sets the questions, who leads, and how are all these elements of science, from what we initially explore to how we test ideas, to how we share our analyses and provide feedback, and what are the benefits and outcomes of science, are truly at the heart of science. And so why not lead with this? Why not provide opportunities for students to discover and document just really how cool the true nature and process of science is? And so by using this flowchart, particularly a newish interactive tool that we have, it can be used as a means of journaling, as a means of documenting a story, a highlight, a particular experiment. And what we really value in being able to share this tool is, it can bring to light to some of those nuances of science that often aren't captured if you're just asking students to, read an article or, engage in an experiment or lab exercise without putting a kind of context in it that is a lot more full. And so, Phoebe, I believe we're going to switch screens now, and I'm going to go ahead and share slides, and I'll dive into this tool a bit more with all of you. And then when we're ready for the breakout rooms, if you'd like to join me in one of the rooms so that we can share, that I can walk you through some of the elements of this tool. And the importance of this particular flowchart, the tool that I'll show when it comes to equity and inclusion in the classroom, is it's a way to really support student learning at all levels, a way to document and show, who does science and how. Students can really get and work through some explanatory knowledge of how they're understanding a particular phenomenon. And we know that science is truly iterative and takes place through a variety of steps and processes. So why not allow that time in the classroom, for students to work through the research process, draw some insights into their own understanding, and provide them with an opportunity to share. So I'm going to walk you through these various bubbles that we see here that are at the heart of science and the heart of this flow chart. And what you will be able to do is, if I can advance the slides here, let's see. Just give me 1 minute here. Oh, there we go. Okay. So if you want to just go to the UCMP Understanding Science website, the URL is there. And when you see the homepage, you'll find the icon for this interactive tool, and you can go ahead and click on it. And there are a lot of other resources on the site, clearly, but the one I want to draw your attention today will be an opportunity to really try out this interactive version of the How Science Works flowchart. And you have a couple of choices when you go to the site. I recommend going to the standard framework, the one that I showed you in the previous diagram that shows the simple 4 bubbles like this is the simplified, but we have time to go through the standard. It's nice to kind of go through the intro. I screen saved a few intro slides just to walk everyone through before we get started. And again, why we get excited about this particular figure, this flowchart, and now the opportunity to work through it in an interactive tool is we want to be able to equip our students with pillars to really build their knowledge of geoscience, and be able to, through investigations, whether it's a laboratory exercise that we've shared with them, or even when we're out in the field, this tool works well on mobile devices. If we're having them read journal articles, this can provide a way really of tracking some of what's going on in a particular science exploration. And so in the tool, and when you select the more complex flowchart, you'll see that these elements of science really come to life. So if we dive into exploration and discovery, it can be driven by all sorts of things, from curiosity to personal motivation. We know the role of serendipity in science and these chance encounters to do great things. And so within that, there are elements of exploration and discovery that are clearly at the heart. At some point at scientists, of course, we're going to gather data and test ideas. So all of those elements are represented here in this bubble. And community analysis and feedback. So certainly peer review, getting input from colleagues through publication, encouraging replication of studies and experiments to validate our findings. It's important to remind students the benefits and outcomes of our work. Science is so essential and core to so much of everyday life, and ways of documenting and reminding that are really great as well too. So again, we're just happy to work with you all to walk you through this tool, and we can dive into it more in the breakout. But as you advance through the various prompts in the interactive tool, you're going to come to a screen where you can just get started. And so you'll get an image like this and prompts to select an event on the map to get started. And so with this, you just begin to click on various points. So say we're being driven in this process by an observation that we've made. And so you're just going to click on areas of the bubble here. So maybe the questions are about, engagement and shaping an activity. What will students be doing? The important thing here to point out is that as you activate this tool, it will make a digital map for you. So the lines representing where you're going on this chart, and then you'll have some drop-down choices on the menu on the left. And so you can add images, you can add data tables, you can type in information, And the important thing is to build out what might be the task at hand. And you can save and document and then share with others. So, and there are various ways of saving and sharing this. So I recommend exporting it as a PowerPoint. So that's what I've done to produce this slide show that I'm illustrating here. You can save it on your computer. It can save as a zip file in a table. I'll just keep walking you through here. Here's an example of saving it to your computer zip file. So however many click points that were generated as part of the use of this tool, and whatever the assignment is, it'll keep track of what part of the bubble that you're in. If there were images that you uploaded, so this is from another exercise I did, there were a couple of photographs that I included. Sometimes other images are used, so show that. And I'll walk you through an example. So Phoebe was kind enough to share this tool with her paleo students at Williams College. And so they made this nice flow chart here. So they were busy, they had curiosity about crab and fish fossils. So they jumped into the exercise and thought it was pretty straightforward and easy to use. So I'll take you through the flowchart map that they generated. And so look at the various things that were driving this exercise. So they had curiosity about a particular fossil group, made some observations, explored the literature, asked some questions, hopped out to the data analysis bubble, proposed a hypothesis, then went and checked some additional data to observe and generate results. They had a new hypothesis, revised, discussed with colleagues. So let me show you what they did. So simple question, and curiosity, paleo students love their animal record, and crabs are definitely very cool. But then you get disappointed sometimes. You want to be crab specialist, but they don't have a good fossil record. But there are plenty of other cool things, right, that lived at that time. So maybe we should spend a little bit of time just looking at some of the other organisms from this time. And, who knew that there's more than 50% of all living vertebrates, ape and fish, but in these periods of time in the past where we see all this changing diversity, why did some things live and others not so much? So let's go get some more information. Let's ask some additional questions. There's lots of rich literature on life particularly during the Mesozoic and the end Cretaceous. We see these really interesting patterns where some organisms increase. So again, we're just encouraging our students to use this tool to document what their understanding might be of particular organismal groups and what are all the connections. So clearly students can have fun with this. And I'll just click through a few more slides just to show you all the possibilities of images that you can upload as one is working through the tool. And then if you save it as a PowerPoint, you have all your images here. You can adjust images and add text in the slides clearly as Phoebe's students did, so that you can represent again and show what your thinking is, what your process is. So Phoebe, I'm going to stop sharing here because I think I'm at time and want to be sure you have time to walk through some of the classroom strategies, and then I can get back to that in the breakouts.
Sounds good. Thank you so much. And yeah, I think I just said in the chat, but my students really enjoyed this activity. And so thanks to Lisa for inspiring me to do it. Okay, so I'm going to talk a little bit now about how I have taken some of the ideas from the literature that we talked about earlier and enacted it in the classroom. And so here's just a few things that I'm going to quickly talk about from my classroom. And I will just, of course, say that this is an evolution for me. These are things that I have been trying out to various degrees, sometimes just a little bit. Now that I have tenure, I have been a little bit more experimental and taking bigger risks in the classroom. But, so I want to emphasize that it's better to take a small step than to not take any steps. And you don't have to make all these changes at once. Okay. because otherwise it's very scary. Okay, so before, and the other thing I want to do before I start is show you one more paper, which is this one, which recently came out and or in 2019, I guess, and it's a real doozy, which is essentially says that students who were in an active learning environment, and this was in a large controlled physics classroom. It was a huge study, chemistry. Basically, students in the active learning classroom learned more, but their perception of learning, while positive, was lower than that of their peers in the passive environment. And so, making these changes will often influence how your students perceive you and your course. And I know many of you in this room have probably already experienced this. And so the one thing that I will say is I want to acknowledge that it's not just especially if you don't have tenure or you're in a, non-tenure track position, and student evaluations are a part of your tenure promotion or retaining your job, that there is risk involved in some of these approaches because of this. And so one of the things that has helped me is actually talking to students at the beginning of the class about what you're doing and why you're doing it. And I think that can really help them understand why you might be doing things differently than maybe a classroom, other classrooms that they are in, or if they're coming straight from their high school classroom environments. And then also framing your narrative and citing research in your tenure and promotion materials is another really important thing, right? If your numerical scores are a little bit lower because you've been trying out these things, citing this paper, for example, can be a way to frame your own narrative around your work as a teacher. Okay. So classroom and community agreements. This is something I started doing a few years ago and has been really wonderful. And essentially just asking, what rules, qualities, and behaviors do we want to have in our class this semester? And so here I'm just showing you the list that was compiled by my paleobiology students this semester. I printed it out, a few copies out, and posted it up in the walls of the classroom, just as a little bit of a reminder. And I think what's really powerful about this is it's not coming from me, it's coming from them. And because that means that they're taking ownership over the classroom environment. And I have found that makes a really big difference when we are having discussions as a class. Policies and procedures on my end, here's just a few that I have been enacting sort of in a rolling way over the last few years. I've really shifted my perception of my students. And so thinking about meeting each student where they are and expecting growth and learning from there. And this is really tricky when it comes to grading, and I'll come to that in a minute. But that what I hope for in my class is growth of the individual student, right? And not that everyone starts or ends at the same place. A few more sort of specific, so that's sort of the framework, right? And well, how do you actually do that? Okay, so here's a few things. No excuse needed extensions. So they don't need to send you an email, explaining why things are late. And I have a set number of those a semester. Regrades on some assignments. This has been really huge because mostly what happens is grading is the worst part of my job. And there's nothing worse than grading and giving feedback and knowing that the student isn't going to look at it. But if you offer opportunities for students to redo assignments or quizzes, they actually have to read your feedback. And I think it actually helps them grow and learn much more. I've moved in many of my courses to a 0 to 3 point grading system, as opposed to letter grades or percentages. And this really de-emphasizes grades. And I have found that anecdotally, I'm not a geoscience education researcher, I'll just say that. Anecdotally, this has lowered student stress and anxiety. So I've had multiple students tell me that this allows them to sort of think less about their grades. And student mental health at my institution, I know at many of your institutions, is really a crisis for many students. COVID was a blessing in some ways because I completely got rid of timed exams, which has also been really wonderful. It forces me to really think differently about how I write exams. But the last time I taught a timed exam, I had 30 to 40% of my students who had an accommodation of some sort. And to me, that just felt like, well, there's a lot of issues with that. Which students are asking for and getting accommodations, which students are not, for example. And then thinking about equity, and if that many students need accommodations, then maybe the system I'm using isn't working. no exams at all, so using multiple low stakes untimed quizzes instead, and having things be open note. This isn't always, not all of these are possible in every single educational situation. I want to make that clear. But acknowledging the reality of what we do, which is that we rely on the internet to answer a lot of our questions. And so, also encourages students to take really good notes. And that's also helped a lot of my students as well. Here's just an example of what my grading rubric looks like for the course that I just finished teaching, paleobiology. So everything is graded on a 0 to 3 scale, and it's on a sort of mastery. Mastery isn't maybe the best word, but that's the best word I have. So thinking about it in sort of like developing, moving towards, and then mastered. And then labs and weekly, I had like an end of the week quiz for each course. Students had 72 hours after I finished grading them to get them regraded. And they just got the higher grade. I know some people who do like an average, and I've done that before too. So, obviously the details are up to you. And so you can see down here, just the way I laid it out. This is the first time I've tried this one. I tried another one last semester. So it's definitely a learning process for me. And it's a learning process for the students as well. But I have seen and heard from students in their final course evaluations that this sort of system has really allowed them to focus on enjoying the class and learning, and not worrying so much about stressing out about exams. There's no cramming, and lowering overall anxiety. And when other professors are not doing that, I think it's really nice for them to have a class where it feels engaging to them and they're not so stressed out about their grades. Okay, I'm going to zoom through a couple last examples. Another thing that I've really been working on a lot is making sure that all my big assignments are scaffolded, to sort of promote a growth mindset. So this is an example that I used this semester, inspired in part by my colleague, Alice Bradley, where instead of final presentations for my paleobiology class, they did posters. So we have a lot of posters up around the department from various conferences. And so we took a class period and just walked around the department. And I asked the students to, think about what made a good poster, and what was, less good. And then we came back and we made a list of things that we thought made good posters. Then I gave them half a dozen sort of fun paleontology papers, and they had to pick one and turn it into a poster. So this one down here, you can see shrinking dinosaurs and the evolution of endothermy in birds. And the students basically had to, read a scientific paper, synthesize the information, and then present it graphically in a way that was going to be, visually appealing. And then I gave them feedback on that, and they could adjust it if they wanted to. And then they made an original poster using the paleobiology database. And so here they were acting as scientists. They were seeing themselves as scientists, and they were also participating in peer review by collaborating with each other and by doing a poster session where they gave each other feedback. Final thing is incorporating texts that explicitly address issues of colonialism and racism into our courses. So the week that we talked about diversity metrics, so how we measure diversity in the fossil record, we read this paper, okay, which is examining the paleobiology database, which is the database used for most fossil diversity work, through a framework of colonial history. And students, I think, were a little surprised that they were reading this paper, but then they got a lot out of it, and the class discussion was very interesting. And at the end of the semester, we read this wonderful paper, Our Past Creates Our Present, Brief Overview of Racism and Colonialism in Western Paleontology. So after spending a whole semester studying paleontology, the students engaged in a conversation of paleontology within a larger social context. And this is just paleontology examples, but there are many other examples of papers written that address similar issues in other subdisciplines of the geosciences. And then finally, self-reflection and assessment. And so I have students do a bunch of self-reflection, formative and summative, grading their participation, reflecting on which of the course goals they feel that they made the most progress on, what worked well for them in terms of their learning and what they could have improved on. And I try to ask them this a few times during the semester. In a large class, that's really hard because I can't read them all, but I think that process is really good. And then thanks to Lisa, I added in this How Science Works module this semester, where the students, after they finished their final projects, the posters, they had to go and fill out this. And so the crab example that Lisa showed was from one of those student poster projects. And for me, I think it was fun for them. It was also really interesting for me to really see how they were thinking about their progress through this project and also what had inspired them. So one student was in a group where they looked at the diversity of ginkgo. And I didn't know why they had come up with this, but in her understanding science framework, she's an international student from China. And so she talked about the significance of picking ginkgo fruit with her mother in her, in her like, why did I do this project? And that was like a piece of information that I wouldn't necessarily have gotten just standing in front of her poster, but obviously had personal significance for her and it influenced her scientific question. So I'm obviously very excited about using this model for future courses as well. Okay, so now we're gonna stop talking and we're gonna ask you to get to work, because when I do workshops like this, for me, the best thing is like actually getting to immediately apply some of the things that I've either learned or been reminded of or gotten inspired to think more about, so that I don't forget about it, especially now that most of us are done teaching until the fall. I know some of you teach over the summer. So we're gonna break people up into two, well, there's gonna be multiple breakout groups, but two categories. Folks who are interested in working on incorporating the understanding science module into an existing lab or activity. And then folks who are interested in thinking about how to rewrite your syllabus or a specific assignment to better incorporate one or more of the inclusive teaching practices that we've been discussing. So I'm gonna hand it off to Bradley, I hope.
It did. I got yeeted.
I was classic in mid-sentence,
I was too, Lisa. I was like,
okay. And I didn't get to all rooms, but just really appreciate some of the feedback that was shared and knowing ways that some of our participants could use the How Science Works tool. And I think in our last just 6 minutes, we wanted to encourage questions, thoughts, ideas, things you want to share about what we shared with you.
Yeah, you can either raise your hand with the reactions raise hand at the bottom, or you can put it in the chat. Either way is great. Julia?
Hello. I have a question. So I would love for my whatever historical geology equivalent life through time to have resources to broaden all of the, like, have queer scholars of paleontology and to replace some of the readings that I've just inherited from previous instructors and come up with ones that are there any resources that have that for, say, paleontology? Maybe this question for Phoebe or Lisa, for just broadening the source of readings that we use if we're using review papers, et cetera.
Mm-hmm. Yeah, it's a great question. There's been a few initiatives in sort of the earth science more largely. The problem is that, like, sometimes people were put on there without their knowledge, and obviously that was not cool. But there's like a really great page. Oh my God, I'm blanking on it right now. Is it 500 Queer Scientists? I would say
I know about that one. I just meant, like, if like, that might be a cool project if some people wanted to look at their intro class together and just invite people to think about it jointly. Anyway, that was my little question.
No, it's a great question. And I know that it's a little tricky in terms of putting lists together of people with marginalized identities. So
yeah, definitely.
Yeah. Mike?
Yeah, so I don't know if this is a question or a comment, or actually could maybe be a whole workshop, but I haven't seen the tool before, and I love this tool on the How Science Works page. And I could see how I could use it to map out some of the stuff I do in class, but also, am I understanding right that like Phoebe also had her students like use it as a reflection so that they could go back and say, oh, this is what we did, and kind of map out what they did and then turn that in? Is that what you did?
Yeah, that's what I did. I use it at the end. So I think you could use it in both, I could have given it to them at the beginning of the project, but it was actually, I think, super interesting to have them do it afterwards, because I think it made them go back and sort of reflect on the process. So I think there's multiple ways to use the tool.
Yeah, I was just thinking of a lot of different ways to use it. We could do like maybe next year at the rendezvous, there could be a workshop on playing around with that tool.
I might just propose that. And we have other sites in what we call our understanding series. There's Understanding Evolution, Understanding Global Change. And Understanding Global Change also has an interactive tool that is pretty amazing. It uses lots of icons and graphics and can really guide an understanding of the drivers and the impacts of global change using concept mapping. And so the project lead for that is Jessica Bean, who was also behind the Understanding Science Interactive. And we've worked with HHMI to build the tool. But yes, so Mike, we really enjoy sharing it with new users and get feedback and information on ways that, one thinks they can use it. But yeah, it's very flexible in how it's applied. So, whatever might work for your courses.
Matt asked a really interesting question in the chat. Have you ever compared how you as the instructor would have mapped out an assignment to how your students later mapped out that same assignment? That's a great idea. I have not done that, but I think that would be super interesting and a really, potentially powerful way to see how, how my brain translates into what they actually do. Yeah.
I agree. And sometimes they don't match, but it'd be good to see again different ways to use for assessment, whether, we're assessing our own ways of teaching or, our students' understanding.
I think maybe we have time for one more question.
Oh, Mia.
So I've been adopting a lot of practices, and especially in my intro courses, to try to increase equity. And something that's missing for me is assessing how well I'm doing, because I don't have access to the demographic data in my class and be able to map that to student achievement or anything afterwards. So I wonder if anyone has any ideas on how you could actually get a sense for how you're doing and if you actually are changing your classroom in the way that you intend.
I think like the self-reflection questions, the end of semester reflection questions, while not quantitative, have been helpful for me because I hear from students about their own experience in the class. So even though I'm not like tracking demographics necessarily, I'm getting that qualitative feedback. Other people have ideas. Yeah, it's a big question, right? Like, how do we know how we're doing?
Yeah, I'm not doing like 5 sections and do interventions in 2 or 3 of them or something. Thanks.
But I mean, the good thing is that other people are doing that. And so if there's a strategy that's working in a large scale intervention, it's probably working for your students too, even if you can't quantify it.
And I just have to, just want to thank everyone and have to say that I have to leave for another meeting. But just thank you all for participating. Appreciated you trying out the tool, asking questions, and thanks to my co-instructor Phoebe and to NAGT for organizing. So.
Thank you, Lisa and Phoebe. Excellent job. Virtual claps. And
thanks, everybody.
Please look for the workshop evaluation that was in the chat, and I think will be emailed to you. All right, everyone have a great day.
Bye, everyone.